Oh, I think we're starting. I'm not ready yet. The stream is starting, but I'm not ready yet. Yeah, I clicked the wrong button. Alright, hello everyone. I clicked the wrong button. It's December 7th. Alright, we did not expect that there was a parade happening, so we rushed home because we don't want to get trapped. There were so many people just stopping on the sky bridge, and we tried to look, and then there was nothing down there. But yeah, we escaped. Good. That was good. We're home before getting trampled. Alright, this is not working. Oh yeah. We try to get a restaurant there, and then we walk in, and they very politely told us to go away by telling us, wow, for a party of 2, it's 1.5 to 2 hours wait. And we're like, yep, that is message received. We know exactly what you tell us to do. I mean, yeah, scramble. This is not working. I have to turn it off for now.
The streaming?
No, not the streaming. The dark mode for this. Oh, I see. It's just I guess it will work. Oh, that is interesting. So it's still not light mode, but it's not as dark. Nah, it's alright. I can read. Alright, we were given a 0 indexed 2D integer array events where event I is start, end, and value, and ith event starts at start time and ends at end time. And if you attend this event, you'll receive a value. You can choose at most 2 non-overlapping events to attend such that the sum of their value is maximized. Return this maximum sum. So in the first one, I have start a 1 and a 3. You know what? We can draw it. I think that's what they're trying to do for us, right? So it's a terrible line. So 0, 1, 2, 3, 4, 5. So 1 to 3, we have a value of 2. 4 to 5, we have a value of 2. And 2 to 4, we have a value of 3. So we say that you can choose at most 2 non-overlapping events, only 2, to attend such that the sum of the value is maximized. So I can have 2, okay? So non-overlapping. Note that the start time and end time is inclusive. That is, you cannot attend 2 events where one of them starts and the other ends at the same time. Or specifically, if you attend an event with end time t, the next event must start at t plus 1, which means this 2 to 4 and the 4 to 5 do not count because they are overlapping. So basically, let's say if we sort them based on their starting time. So in this case, we have 1, 3, 2, 4, and 4, 5. And then for each one, we will be able to find who is to the right, the non-overlapping one, I'll be able to find. And I need to pick one of them, which is the largest, right? Which I need the largest of the remaining. And then for the second one, I'll do the same. So for each one, I'll pick each one and I'll find the maximum in the remaining. Okay, so the question is, how do we find the maximum in the remaining? We have all of those, right? All of those. And they have a starting time. Actually, the only thing we care is the starting time. So it's like, so we have a starting time and we have a value, a starting time and a value, starting time and a value, right? And what I want to know is from this to the end. So it's like a prefix max, right? What is the maximum? So we can go like from a right to left. Yeah, we can go right to left. A suffix max, right? A suffix max. So we have this array, right? We have a starting time and we have a value, right? And we sort them, so we have all these tuples, right? Starting val and a val, right? And then if I go this way to find a maximum that have been counted so far, then when I binary search on the end, right? Binary search on the end, then I say all of these can be possible. So I just need to find the maximum because I know the max up until this point. Okay, we have a data structure, we have an algorithm, so we just need to implement it. What is the implementation for this? I know. Hold on. Just hold your horses. Hold your horses. What I need is everything. So I need to sort the original events. Okay. I sort the original events and I need another array for the prefix suffix max. And that shall be it. Okay, so we need to sort. We need to sort. Let's sort this baby. Let's sort this baby. How do I sort? Do you remember how you sort? I honestly do not remember, but we can always look it up. So what I say is it std sort? Events. How do I check? Oh, I forgot. Is it K? No, I can't see the definition. Maybe GD doesn't work. That's fine. I mean, we can just go here, C++, sort. Sort. Oh, first, last, and compare. My bad. So it's not. My function. Do they not have like a lambda-ish thing? I remember I saw a lambda here. std, great. Huh. A struct operator. Here. Lambda. Got it. So basically we need to say events dot begin, right? Events dot end, and we'll do this is a lambda. This means everything is I forgot. What does it mean? This means nothing gets passed in. Wait, hold on. C++ lambda. Can only access variables which are local to it. Capture all external variables by reference. Capture by value. Oh, you can access this Though that means usually I won't be doing this, right? Because I can just say, oh my god, it's gonna be a vector. Alright, vector B return A 0 smaller than B 0, because we want to sort by that, by the starting point. Okay, so I sorted and I need another. Do I do another vector or do I do an int array? How do I initialize an int array? Int array. Declare an array of size. Okay, so we can say int. Wait, it cannot be dynamic, right? I think it cannot be dynamic. It has to be. I mean, it's not really dynamic. It's. No, I think it has to be. Yeah, I don't think there's any way for you to set a dynamic length. Dynamic size. I don't think so, if I remember correctly. New operator. But you have to delete it at the end. Ah, I think that's why. Why bother, right? You just use vector. Yep, we'll use vector. We'll use vector. Of course, use vector. And vector can do size too, right? C++ vector size. Now define vector with size. Initialize vector with size. Can I do dynamic size? Oh, I can. Vector numbers. I think I can. So we just say std. What's std? Vector? Int. What do I say? Std vector int suffix max. Events suffix max. Hold on, let me think. All right. Oof. hold on, sof max n minus 1 shall equal to events n minus 1, 2. So we start from here. I shall equal to max events n minus events I 2 sof max I plus 1. Okay. Now I need to go from front. Int res equal to 0. Alright, go from front. For each one, then we'll just binary search for auto event of events. Okay. And then binary search. So basically, binary search, we need to search the remainder because I sorted already. So search for the start. How do I do the search? The partition range of elements to examine, value to compare, and then comp. What's the return? It doesn't return. What? If element to false otherwise. It doesn't give me an hold on. It doesn't give me the index? What in the world? I have a lower bound. Oh no. I think we have to roll our own. Oh, hold a second. Is used to find a first element in a given range that is greater than find the first one that's greater than or equal to the given value. This is the lower bound. What do you need? I think I need the upper bound. First element in the given range that is greater than, first in the greater than, that is greater than a given value. Oh, it returns an iterator. Oh, it returns an iterator. It doesn't have an index. Oh my god! All right, we have to roll our own if we want index. Or iterator to index. Is it possible? Distance. Uncle Ben. I remember on YouTube I saw this name before. Okay, we'll use this then. Alright, so we'll combine the two. We'll use upper bound, which returns the first element that is greater than the given value. That is greater than the given value. Okay, and comp, I think I can do something like this. Okay. So, oh my goodness. So do I do auto? Upper bound. Right. Vector star. So events dot begin, events dot end, the current event, and we need to do a comp. I think we say const a. I'm not sure if that's the right way to go. I think you should say a vector a, vector b, right? What are we comparing? I'm not sure if we can even do that. Yeah, I'm not even sure you can do that. Screw this, I'm gonna roll it myself. Events. Alright. And I do an int and okay. Low, high, okay. Then basically we just want to see the starting point, right? This is the end, this is the starting point. So what you want is if events mid 0 is the starting point. If the starting point is larger or equal to your end, or smaller or equal to your end, smaller or equal to your end, right? If it's smaller or equal to your end, right, and it's here, so I need to move forward. I say low equal to mid plus 1, else high equal to mid, right? If it's larger than myself, then high move in here, right? If it is smaller or equal to low, so at the end I will return low. So basically this is not subscript value. My bad. I think as another vector. Right, so this will give me the index of the value that is larger than end, okay? Larger than end. So what we're doing here is int index equal to binary search. I don't know, can I even call it binary search here? Events event 1. Okay, so the index yeah, we pick every single one, and what I want to see is if the current event and is really large, right? Nothing starts after it, then there's no possible, right? So we'll say if index is smaller than n, right? Index is smaller than n, then res shall equal to std max res the current event plus events index, because index is the one that's larger than the end. This one too. So we go through this, then we will return res. Maybe there is some kinks that we need to iron out, but I think overall it should be right. So binary search, right? Let's say sort events, and then for each event, binary search, right? To hold a second. Sort events and produce, right? Sort events by starting point and produce a suffix max array. Produce a suffix max array to record the max value from events I to the end. Then for each event binary such, the sorted events to find the first index whose start is larger than the current event's end. We then use the suffix max array to find the max value, right, from the max value achievable from that index to the end. Oh, and log in. And this is not right because I need to use the suffmax. O1 login. This is O1. This is O1 login. Okie dokie. Let's see if it compiles. Whatever happens, this is a that ain't right. The second one's not right. First and third is right. The second. Oh shoot! At most two. So you can choose only one. What did I choose? Hey, not supposed to get 4. How did I get 4? Oh, 1, 3, 4, 5. Got it. Alright, so we need to make a little bit change. Just a little bit change. Na 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 na. There you go. I think adding this one shall make it work. Basically, we're just saying let's also try respecting the each value by itself. There we go. All right, you're kidding me, man. This is ridiculous. How? Why would it be so bad? Because I wrote my own binary search? Maybe there's some early exit. Let me think. Maybe there are 2 sorting. I'm thinking about 2 sorting. we sort by and, okay, we sort by and. Then for each one, and then we also have another one sort by start. Then we have two pointers, one pointing at the end and one pointing at the start. Smallest, so the smallest end is the smallest start that's larger than this end. We do that and move forward, start, move back. Okay, that's actually another way. Maybe. So I have a second solution which I need to sort. I need to create two more. One is and the other is start. What is your appetite for that? So we say a vector of end and value, right? End and value. And the start and value. And we update the value. Pair. And I don't know, how do we define this? Okay, starts. How do I use pair? Make pair. That's the one you're looking for. Event 1, event 2, start, stop, push back, event 0, and 2. Okay, then we just sort. Std sort and begin and start and oh there we go. It off first. Starts. Yes. And then for we can say starts I dot second and starts plus 1 second. Okay, so yeah, we can say this is a suffix max for int. Let's just go through every single one. And we need a j. Say while and starts j dot first is smaller or equal to and I dot first j plus plus, right? If j is smaller than n, oh, we should put this one here as well. Right. If j is smaller than n, then we can say, actually no, I need to go through the whole thing. And I dot second, okay, and res equal to std max res and I dot second plus starts j dot second, right? Because it's a suffix max, so I go through this and this. And then JL plus plus, IO plus plus, I plus plus. Well, we'll check J. If J is no good, we move J forward until J is good, right? And the rest. This is a 2-pointer solution without binary search. Okay, let's see if this one works. Looks like it works. It's just binary, so it takes a lot of time, I guess. So 2-pointer it is. I mean, this is still log n. Probably because I wrote binary search myself. Now I want to see if, yeah, probably I use the built-in binary search. Maybe it'll be faster. Maybe. Anyway, that should be good enough. Oh, DP. Lord has mercy on me. How'd you do DP? It does not appear to me. Ooh. We're at index and we have done 0 or 1, right? I think that's what it's trying to say. Oh, 102 event. So we'll say the end. And now we binary search. Look, we have a binary search here. Binary search move to that. Include. So basically, so we'll find a maximum, the current events plus lowest smaller than size. Oh my god. Here. Lowest smaller than size and events low 0 is larger than and. Because of course that's how you do it. And then we'll find the maximum count plus 1 exclude is by itself. Okay. Mean heap. What in the world? Oh, that was simple. End time with value. Greater. I think this is the function. What? A vector of pair, okay. And this is each element. This is the overall elements. And we'll sort this for event of events. Pop all events from Q and take their maximum. Wait, what? I don't understand. Pop all events from queue. Okay, let me see. I don't understand this one. Find a maximum valued event that ended before the current event. Is the value. Is that an easy way to add a pair? It's not a value, it's the end. End and a value. So we will pop the oh, so for each one we look to the left. So for each one we look to the left, right? We just want the biggest value that has no smallest. So for each one, oh, this is producing a prefix max. So for each one, I find the prefix max, right? The maximum of those whose ending is smaller than the current start, whose ending is smaller than the current start, whose ending is smaller than the current start. And for each one, I'll try it, right? I'll try it. I try the max val. So this is basically produce the max value of what we've seen so far. Ah, I see. Okay, that's good. I shall try this one. Learn how to use priority queue. And we have a greedy. Oh, greedy still over login. Okay. Start time. 0 denotes end time. If current time is a start time, find maximum sum. Max value. If it's end time, it's kind of the earliest end time because you sort based on the first. end time processed before start time in case of tie, so we can iterate through sequentially. Oh, it's the same idea. It's the same idea because you sorted it. So when we check the current start, then we can directly use the previous max, right? We just use the max value. So, okay. So we have ending point to the left. So when we start, makes sense. Makes sense. But I like the priority queue. I definitely like the priority queue method. We are going to do a third one, which use the priority queue method. Alright, how do we do priority queue? Priority queue something. Oh, it's a max heap. We want the smallest to come on top. Yeah, we put the end time in it, then the smallest come on top. Look at this, priority queue, in heap. So, okay. Is originates from the official solution with the priority queue. For each, we sort event, right? We sort events by starting point. Then for each event, we look to the left. Right, we look to the left. We look to the left. Yes, we look to the left to find the max value so far with endings smaller than the current event start. Essentially, we are creating a prefix max using priority queue. Okay, so we'll have a pair. It's gonna be a vector Alright, it's a 1 hour, so we're gonna end here. I'll keep programming this thing. It's not hard, but we just need to get used to all the C++ stuff. Yeah, I'm gonna end right now. I will see you guys. Oh my goodness, this is and std creator. Okay, I'll see you guys tomorrow. Adios.